Okay. If we want to compare how two numerical variables of data differs, we can test on paired data. Paired data means that each entity in our data set has two properties. Yeah? Let's make an example to make this clearer. Yeah? Let's say you have a stellar survey, some catalog of stars, and for these stars, they give the positions, of course, and they give brightnesses in the B and in the V band. Yeah? So you have a table with stellar names or catalog numbers, B and V. If you have such a set of observations, that you call this paired. And to use the same scheme that we did before, namely test against one mean value or one number, is that we do a difference between B and V, between these two properties, and then test the difference. Yeah, for example, we could check is the difference 0, is it always positive or negative or whatever. Okay, so I compute here the difference, and then I perform my test on this difference. So the parameter of interest here is the average difference B minus V of all stars. The point estimate is here the difference in our sample. Where we can do the statistics. So here the mean value is minus 0.55. We have a standard deviation of almost 9, and we have 200. And the hypothesis test again is the difference is 0. There's no difference between B and V. And the alternative means it's not 0. So we reduced our paired problem to what we did earlier. Yeah. Okay, same game. And here's then the result. This is a typical case for two-sided test because we are testing not equal. So this is the normal distribution of our sample. Mean value is 0 under the null hypothesis. The standard error is this. And the C score is minus 0.87. Yeah, that's here. Equivalent to minus 0.54 in this distribution. And the p-value for this two-sided is 38%.